Have you ever wanted to just spin up an entire application stack with a single command? I'm talking multiple containers, complex networks, persistent data, everything talking to each other perfectly. And then, when you're done, tear it all down just as easily? Well, today we're pulling back the curtain on the tool that has become the absolute secret weapon for so many high-performing dev teams, Docker Compose. And we're not just doing a simple tutorial. We're going to get into the why behind the what and really see how this thing completely revolutionizes the way we build and test software locally.
All right, here's our game plan. We're going to start by feeling the pain of the old way of doing things, the manual way, so we really understand the problem Compose solves. Then we'll have that big aha moment when we build our first stack. After that, we'll get serious with a real-world application, and then we'll dive into the super important differences between dev and production. We'll also settle that classic debate, Compose versus Kubernetes. And we'll wrap it all up by showing you how this fits into a professional, modern DevOps workflow that you can literally start using today.
So let's start by rewinding the clock a little bit to a place that might feel, well, uncomfortably familiar for a lot of us. We're going to talk about the world of individual Docker run commands and see exactly why trying to build a real application that way is like building a house on sand.
Oh man, this thing. We have all been there, right? You just need a database for your project, and suddenly you're staring down this monster of a command. Let's really look at it. First, you have to remember to create a Docker network where nothing else can talk to it. Then you're digging through the Mongo image docs to find the exact environment variable names for the username and password. Then you got to get the volume syntax just right so your data doesn't just vanish when the container stops. It's long, it's brittle, and let's be honest, it is a nightmare to type correctly even once, let alone every single time you need to start your database. And that was just for one service. This is where the whole house of cards just collapses. A real application isn't just a database. You need your Backend API. That's another giant Docker run command with its own ports and variables. Then you add a Redis cache for performance. Boom, another command. A front-end web server? You guessed it, another one. Before you know it, you're trying to juggle 4 or 5 of these massive commands, hoping you got all the network flags right. You might throw them in a shell script, but now you just have a messy, error-prone script to maintain. It's a system that actively fights you every step of the way. So, all that chaos brings us directly to the solution, and it's an elegant one. Docker Compose is a fundamental shift in how we think. Instead of telling Docker how to set up our world, step by step with all those commands, we're just going to describe the world we want to exist. We'll let Compose be the genius that figures out the details. And the heart of it all is this one single file, docker-compose.yml. Think of it like a blueprint for your entire application. It's written in YAML, which is just a super simple, human-readable way to organize information. Inside this one file, you define the whole shebang, all your services, the networks that connect them, the volumes for their data. And the best part? It's just a text file. You check it into Git right alongside your code. Now think about what that means. A new developer joins the team. They clone the repo, run one command, and they have the exact same development environment as you. The whole, well, it works on my machine problem, gone. It is a massive, massive leap forward.
And look at this comparison. It's night and day. On the left, you're the micromanager, barking out every single tedious instruction for every single container. It's exhausting. On the right, you're the architect. You're just describing the final vision. I want service called MongoDB using the Mongo image and another called Mongo Express. You're defining the what, not the how. Compose reads that blueprint and acts like your general contractor, figuring out the right order, building the networks, and making your vision a reality. So let's break down what's actually in one of these service definitions. It's not scary, I promise. These keys map directly to those command line options we hated. Image is for a pre-built image from Docker Hub, or builds can point to a local Docker file for a custom image. Ports connects a port on your machine to a port in a container, always host/container. Environment sets your environment variables. Volumes is for data, which we'll get into more. And restart is a lifesaver. You can set it to always, and if a container crashes, Docker just brings it right back up. It's all the same power, just organized and easy to read. And now for the magic trick, the one command to rule them all. You navigate to the directory with your Docker Compose YAML file, you type this, and you hit Enter. Compose reads your blueprint, creates a dedicated network, builds any custom images you have, and then starts all of your services. That little -d flag just means detached, so it runs in the background and gives you your terminal back. One file,
one command, and your entire application stack is up and running. It's incredible. Okay, theory is great, but let's build something that looks more like a real-world application. The true power of Compose isn't just launching one thing, it's orchestrating a whole symphony of services. So let's design a classic stack, a Backend API, a Postgres database for our data, and a Redis cache to make things snappy. So once these three services are running, how in the world do they actually find each other and talk? This is where Compose really feels like magic because it solves a problem that used to be a huge pain. When you run docker-compose up, it automatically creates a private, isolated network and attaches all of your services to it. They're all living in their own little world, completely ready to communicate. And this right here is a complete game changer. Your application code doesn't care about IP addresses anymore. You simply use the service name you defined in your YAML file, like DB or Redis, as the host name in your connection string. That's it. Compose has a built-in DNS resolver just for this private network. So when your API says, hey, I need to connect to DB, the DNS says, oh, DB? Yeah, that's this container over at this internal IP address, and the connection just works. This is also why trying to use localhost from inside one container to reach another is a classic rookie mistake. Localhost inside a container always means that container itself, not its neighbors. Okay, networking is sorted, but what about our data? A key thing about containers is that they are ephemeral. Think of a container's file system like a whiteboard. When you're done, you wipe it clean. If your database saves its files inside the container, restarting it is like wiping that whiteboard. Poof, all your data's gone forever. This is what volumes are for. By defining a named volume for our database, we're telling Docker, hey, see this data directory inside the container? I need you to store that in a special, safe place on my computer. This means our precious data will survive restarts, updates, and even a complete Docker compose down. All right, listen up, because this detail is what separates the pros from the amateurs. You need your API to wait for the database, right? So you use depends on. But here's the trap. Depends on only waits for the database container to start. It does not wait for the actual Postgres application inside it to be ready. This creates a race condition where your API starts up, tries to connect to a database that isn't ready, and just crashes. The pro move is to add a health check to your database service, a little command that checks if Postgres is actually ready to accept connections. Then you change depends on in your API service to wait for the service healthy condition. Now your API will patiently wait until the database is truly ready. This makes your local stack rock solid. So we've built this awesome, robust local setup. So we can just copy this docker-compose.yml to our production server and we're done, right? No, absolutely not. It is so crucial to understand that how you use Compose for local development is fundamentally different from a production mindset. In development, our goal is speed. We use the build directive, and we mount our source code directly into the container so we can get that amazing live reloading experience. But in production, our goal is stability and predictability. You never mount source code in production. Instead, your CI/CD pipeline builds a self-contained, unchangeable, or immutable image. That image, with your code baked right in, gets tagged with a version and pushed to a container registry. Your production environment then uses the image directive to pull that specific, pre-built, pre-tested image. There are no surprises. What you tested is exactly what you deploy. All right, here are the landmines. Please avoid these. The biggest one. Never, ever hardcode secrets like passwords in your Compose file. That file is in your Git history. Use a .env file instead. Compose will load it automatically. Forgetting a named volume for your database is a painful mistake you will only make once. And please, pin your image versions. Using the latest tag is asking for your build to randomly break one morning because some upstream project pushed a breaking change. Don't do it. Okay, time to address the elephant in the room, the question I get all the time. So if Compose is this great, why do I even need to learn Kubernetes? Is this just a replacement? The short, simple, and correct answer is no. Absolutely not. They are different tools for different jobs, at vastly different scales. I love this table because it makes it so clear. Think of it like this. Docker Compose is your personal workshop. It's designed for a single machine, your laptop. It's fast, it's simple, and it's perfect for building and tinkering. Kubernetes, on the other hand, is the fully automated global-scale factory floor. It's designed to run your application across a whole cluster of machines, providing things Compose was never built for, like automatic scaling and self-healing if a server goes down. So you don't choose between them. You graduate from one to the other. You build and test with the simplicity of Compose, and you deploy to the power of Kubernetes. Okay, we have covered a ton of ground. We know the what, the why, the how. So let's put it all together. What does this actually look like, day to day, for a developer on a modern team? This right here, this is the daily loop. And it is beautiful. You start your day, you git pull, and then one command, docker compose up, brings your entire world to life, perfectly identical to everyone else on the team. Need to run a database migration? Docker compose exec gives you a shell right inside the container. Trying to debug something? Docker compose logs-f gives you a live streaming view of the logs. And at the end of the day, Docker compose -v cleans everything up. Containers, networks, even the data, so you can start fresh tomorrow. It is clean, it is repeatable, and it is so, so efficient.
But wait, there's more. What if you need to test something a little trickier, like how your app behaves with multiple database replicas? You don't need some complex staging environment for that. You can do it locally with a scale flag. With this one little addition to your command, you're telling Compose, hey, forget what the file says for a minute and give me 4 instances of the database service. It makes testing things like service discovery or load balancing trivially easy, right on your own machine. So I want to leave you with this question. Think about your own workflow right now. What's that one manual, annoying thing you still do every single day? That database you have to start by hand? That Redis instance you always forget to launch? You can take all of that manual pain and capture it in one simple docker-compose.yml file. You can bring this level of sanity and automation to your own work starting this week.
If you enjoyed this deep dive and you're ready to really level up your skills, make sure you hit that subscribe button. In our next session, we're going to be tackling infrastructure as code with a huge look at Terraform and how you can define your entire cloud infrastructure with just code. It's another one of those foundational skills, and trust me, you do not want to miss it.